All right, so here's day 5 of Unit 1. Yesterday, on day 4, we talked about single angles, like different vocabulary, how to name a single angle, all that good stuff. Today, we're going to talk about special angle pairs, right? So if you have two angles, maybe they have a special relationship with one another. Because remember, this class is all about being able to analyze a diagram or a situation and find a relationship. Okay, and so we're going to talk about some special angle pairs. There's 5 of them that we're going to talk about today. So the first one are two angles that share a vertex and a common ray. We actually talked about this yesterday. I'm going to draw that picture really quick. So here's a single angle, right? And we want to add another angle that also shares the same vertex and a common ray. So one of their sides have to be in common. Okay, so I'm going to zoom in. So this little guy right here, this would be the common ray or the common side, okay, from that definition. So basically it's just two angles that are next to each other. And if you remember from yesterday, the word for next to that we use for angles is adjacent. So that popped up in one of our definitions yesterday. So just going to reiterate that today. Okay, so two angles that are directly next to each other, they share a common ray, they don't overlap in any way. That is called an adjacent pair of angles. Now, I know we're mostly learning this as a vocabulary word. There technically is no special relationship happening here. I'm going to write that here. No special relationship. And what I mean by a special relationship is that I know something about these two angles that would allow me to set up an algebra equation, right? I would have to know that they were congruent or that they added up to equal 85 degrees or whatever. But we don't know that about adjacent angles. Adjacent angles are just two random angles that are next to one another. So there's really no special relationship. So when somebody tells you you have adjacent angles, you're like, okay, great. And what else about them, right? Because that doesn't lead me to any actual information that's usable, okay? All right, our next one, these are words you might have heard before, all right? So two angles are called complementary. Such a long word, complementary, if the sum of the two angles is exactly 90 degrees, right? So two angles that add up to equal 90 degrees. Now, these angles do not have to be adjacent, but they can be. So I'm going to just kind of draw two examples over here. So let's say, for example, I have a 40-degree angle floating around in space. Right, and he wants to latch onto his complement, right, is what we would call that, right? And so if they have to add up to 90, well, then he's hunting around for a 50-degree angle, right? Let me actually. Right, so let's say this guy is 50 degrees. So these two angles would be complements of one another, right? Because if I add them together, they equal 90. They're just floating around in space. They're not adjacent to one another, right? And so we would still call them complementary angles. Now, of course, for us, the majority of the time, they are going to be adjacent. And so, of course, if I put two angles together that add up to 90 degrees, well, they, of course, then form a right angle. And as we talked about yesterday, right, if I have a right angle, I can show that by putting a right angle box in the corner. Okay, so they can be non-adjacent or adjacent. It just looks a lot better if they are adjacent because then I can actually see that right angle. All right, our next pair of special angles would be supplementary angles. And of course, their sum, you might have heard that word before, is 180 degrees. That is their special relationship, right? They add up to be 180 degrees, right? And so again, the same kind of thing holds true. They do not have to be adjacent. So I could have this like 100-degree angle floating around in space, and he's just searching for his supplement. And of course, that supplement would have to be an 80-degree angle, right? So that when I add them together, they add up to 180 degrees. Or of course, most of the time we would see them adjacent to one another, in which case they would form a straight angle, right? Since they add up to exactly 180 degrees. Right, so supplementary angles will always add up to 180. If they are adjacent, they of course will form a straight line or a straight angle. All right, and then our fourth term here, this is actually just piggybacking off of number 3, right? Because supplementary angles don't have to be adjacent. If they are supplementary angles and adjacent to one another, then we actually have a more specific name for them, and we call them a linear pair, which I'm hoping makes sense, right? Pair meaning two angles, linear meaning line, so two angles that form a line, right? So they have to be adjacent and supplementary, so we refer to them as a linear pair, and of course they would have add up to 180 degrees, just like all supplementary angles do. All right, the fifth pair, this is our final one of special angles. This is my favorite one that we'll use almost daily in here, right? So clearly you can see in this diagram underneath number 5 that we have two intersecting lines. Often I encourage students to use highlighters to highlight intersecting lines, especially in pictures that have a lot of lines going on, right? A lot of rays and angles, because not all the lines would technically be intersecting, and we'll talk more about that when we get down to the next page. But anytime two lines intersect, clearly 4 angles are created, right? That's going to happen no matter what. 4 angles will always be created when two lines intersect one another. So what we're going to be talking about today is the opposite angles that are formed by two intersecting lines, right? And so, right, like 2 and 4, right? Those would be opposite angles formed by the two intersecting lines. And then of course 1 and 3 would also be opposite angles formed by the two intersecting lines, right? These are called vertical, oops, sorry about that. These are vertical angles. Right, vertical angles, super important. Like I said, we're going to be working with these almost every day. And so obviously in the little box over here, the vertical angles, like we just highlighted, angles 1 and 3 would be a vertical angle pair, and angle 2 and angle 4 would be a vertical angle pair. Now, there is a special relationship that vertical angle pairs have with one another, and you can probably look at this picture and just tell me right away what you think that is, and you'd probably be right. However, I'm going to be slightly annoying, and I'm going to make us talk this through in like the most minute baby steps you can possibly think of. And I'm not trying to be annoying, right? I'm trying to plant the seed in your brain of learning how to slow down your thought process and justify every single step that we do in geometry. And I want us to start in this process, right? We've been talking about it the last few days, like justifying all of our equations as we write them down, all that good stuff. We want to start getting in these habits, right, for when we start our geometric proofs in Unit 2, where you will have to justify every single step of work that you do, right? So if we start that now, right, our brains are going to start being trained to do that. Okay, so here we go. If you look at this little blurb right here, suppose the measure of angle 1 is 40 degrees. Okay. So we're going to do what I would call an informal proof, right? Informal proofs use actual numbers to prove other numbers, right? We will actually do the formal proof, which does not use numbers, later on in Unit 2. Okay, but for now, we're just going to kind of talk through this so we can just kind of see how this works, okay? So if angle 1 is 40, I should be able to find the measure of all the other 3 angles, okay? And that's going to actually prove the relationship that we're looking for. Again, I know you can probably tell me what all those angles are right away, but let me just kind of slow it down just a little bit. All right, so I'm going to look at angle 2. So I want to look at the relationship between angle 1 and angle 2. All right, and so we're going to go back here and we're going to say, you know, which out of these 3, which relationship do we have? Now, to be the most specific, we would call that a linear pair, right? Because the 2 angles form a line. Okay, so we have, I'm going to kind of write this thought process down. We have a linear pair. Angles 1 and 2 are a linear pair. And of course, if I have a linear pair, that means the angles are supplementary. And if the angles are, sorry, I'm trying to write and talk at the same time, supplementary, there we go. If the angles are supplementary, that means they add to 180 degrees. Right, so I looked at my picture, I'm like, hey, angles 1 and 2, they form a linear pair. What do I know about linear pairs? They're supplementary. What do I know about angles that are supplementary? They add up to 180 degrees. Notice it was actually 3 different trains of thought that got me to the fact that angle 2 then of course has to be 140 degrees, right? Because I know the angles have to add up to 180. Again, I know you probably could tell me that 5 minutes ago, right? But we want to train our brain, right, to justify every single thought process that we have, okay? Now I'm just going to kind of continue that thought process around the picture. So far, now I can go look at angle 3. Well, angle 3, he's a linear pair with angle 2. Which means those angles are supplementary, which means they must add up to 180. So therefore, angle 3 must be 40 degrees. And we continue. All right, now when I get to angle 4, the cool thing about angle 4 is I can either use the linear pair with angle 3, or I could use the linear pair with angle 1. He forms a linear pair with both of them. All right, so either way, he's a linear pair with a 40-degree angle, which means they're supplementary, which means they have to add up to 180, which means his measure must also be 140. Okay, so now I want to talk about what we've just proven here, basically, right? Look at our vertical angles, right? What relationship do you notice? Well, 1 and 3 are a pair of vertical angles, right? And they are both 40 degrees. So they have the same measure, which means we would call them congruent, right? And angle 2 and 4 are vertical angles, and they are clearly congruent because they have the same measure. So that brings us to our very first major theorem that says if 2 angles are vertical, then they are always congruent. And that is called the vertical angles theorem. And yes, you must memorize the names of these theorems, or else you'll have to memorize all the wording of the theorems, either one. The vertical angles theorem. Please do not confuse the difference between the definition, right? This is the definition of vertical angles. Oops, I'm gonna write that kind of up here. Right, this is the definition. Right, the definition of vertical angles is two opposite angles formed by 2 intersecting lines. Right, that's the definition. Notice it doesn't say anything about congruent anywhere in that sentence, right? The definition of vertical angles just tells you what they are, right? Or how they're formed, I should say. The vertical angles theorem actually gives us the relationship, right, between vertical angles. Okay? And of course, if I wanted to, I could then write down that angle 1 is congruent to angle 3, and angle 2 must be congruent to angle 4. And I can now assume that, now that we've learned this new relationship, now I could put, as soon as I see vertical angles, right, in a diagram, I can instantly put congruency marks in there and instantly know that the measures of those angles are equal to one another. So I could set up an algebra equation and I could solve for x and I can find the measures of the angles, right? So that's pretty much all we're going to be doing in this class for quite a while, right? We're going to be looking at pictures, we're going to be finding relationships so that we can set up algebra equations, okay? All right, so here we go. Really quick, I'm going to fly through this. Obviously, some of these have more than one answer, so I'm just going to put one of them down. So we're going to list the angle pair and the relationship. Okay, so let's see. An adjacent pair of angles. Okay, well, that would be any 2 angles that are next to each other. I'm just randomly going to pick angle 4 and angle 5. Right, so these 2 angles, they're of course next to each other. They don't have a relationship with one another, right? Because adjacent angles doesn't really tell me much unless there is something else happening in the picture, right? But they're just next to each other, so no real special relationship going on. All right, complementary angles. Well, complementary angles add up to 90, so I'm looking for that right angle box. There it is, right there. All right, so I got my right angle box. okay, which tells me that angle 3 and angle 4 are complementary, which means they add up to 180. So the relationship, if I wanted to write an algebra equation, the measure of angle 3 plus the measure of angle 4 has to equal 90 degrees. The cool thing about this picture is you could, of course, also said angle 1 or 2, because I can prove, since this is a straight line, right, I can prove that if 3 and 4 form a right angle, then 1 and 2 must also form a right angle because they have to all add up to 180 degrees, right, since they form that straight line. Please be really careful. I would not call these angles supplementary, right, because supplementary only refers to pairs of angles that add up to 180. So if there's 4 or 5 or whatever angles, they can still add up to 180. I just wouldn't refer to them as a linear pair or as supplementary, okay? All right, the next one is supplementary. So I'm looking for two angles that form a line. Well, there's a couple of options here. I'm just going to pick angle 1 and angle 6, which of course their relationship is that I should be able to add them together and they equal 180 degrees. So it's all about the relationship that allows me to set up an algebra equation. All right, a linear pair. Now, because all of these angles are adjacent, then all of my linear pairs are also going to be supplementary and vice versa. Just for the sake of picking a different pair though, I'll just pick 5 and 6 in this case. All right, so the measure of angle 5 plus the measure of angle 6 equals 180. But do realize, of course, that these two questions, because of the picture and everybody's adjacent, they are the same question, right? All the linear pairs will be supplementary. And all the supplementaries will be linear pairs. And then the last one is vertical angles. This again is where you want to be careful because there's a lot of other rays that are not connected, like would not be considered intersecting lines. So I would always suggest, if you're having a trouble reading the picture, right, I'm going to highlight my intersecting lines. These are the only two lines that are intersecting. The rest of these rays over here are just shooting out from that vertex there in the middle. And so I'm looking for two opposite angles formed by the intersecting lines. And that would clearly, or hopefully clearly, only be angles 1 and 5 that I can name singularly. So angle 1 and angle 5 are vertical angles. And of course, the vertical angles theorem tells me that the relationship is that they are congruent, which of course, algebraically speaking, means that if two angles are congruent, then their measures are equal. Okay. Now I have another pair of vertical angles, except it would be angle 6 with 2 plus 3 plus 4. I just didn't want to write all of that, right, because that's a lot. But 2 plus 3 plus 4 would be equal to angle 6, right, because those are vertical angles to one another also. Okay. All right. We're just going to work through some examples. I'm going to go through these really quickly. If you need to pause and rewind, feel free, obviously. So it says two angles form a linear pair. Well, I'm going to draw a picture for this. You don't have to, but we'll talk more about that in a second. So I'm going to draw two angles that form a linear pair. Here we go. And again, I have no idea what the measure of these angles are. I'm just drawing a visual for myself to make sure everything's in the right spot. All right, then I'm going to try to label it. It says the measure of one angle is 3 times the measure of the other. Okay, so just kind of like in Algebra 1 where you would translate verbal sentences, we're going to do that here. Obviously, one of my angles needs to be x. That would be the other, quote unquote. And then the other one is 3 times the measure of that one. So I would label him 3x. And that's it, right? I've drawn my picture, I've labeled it, and now, because obviously they form a linear pair, there's obviously a special relationship, and that of course would be that they are supplementary, therefore they add up to 180. And that's a pretty easy algebra equation to solve, so we end up getting x equals 45. So one of my angles is 45 degrees. Just going to write that over here, a little colon. And then the other angle would be 3 times that, which would be 135 degrees. And then I'm going to do a quick check before I box up my answer, right? So I already know 135 is 3 times 45, but do they all still add up to 180? Yes, they do, right? And so all my numbers work all the way around. All the relationships are happening. So we are good. So I'm gonna put a little smiley face. I've checked my work. I know, of course, that that is good. All right, down here we just have some intersecting lines. The cool thing about math, right, is once you start learning more and more relationships, there's more ways to solve the problem. So the way I might solve a problem may be completely different than how you solve the problem, and that's okay as long as we're using proper relationships, okay? So this problem, I'm noticing I have two different variables. I don't really want to work with two variables at the same time because that would require me to have a system of equations. So I want to avoid that if I can because that's a lot more work. So if I want to try and see if there is a relationship happening between one variable at a time. And I definitely see that here, and I'm hoping you do too, that if I look at my two angles that only have x's in them, those are vertical angles, right? And what do we know about vertical angles? That they are congruent because the vertical angles theorem tells me so. And if angles are congruent, that means they are equal in measure. So I can set the 3x plus 7 equal to the 5x minus 35. So that's going to give us, let's see, I'm going to add that over. So we're going to get x equals 21. Now, I am going to go ahead and write that here, but not before I check my answer, right? I'm totally going to plug that in to each of these angles. So 3 times 21 is 63, plus 7 gives me 70 degrees. And then if I plug it in on the other one, 5 times 21 is 105, minus 35, oh, what do you know? 70 degrees. So I've checked my answer. I got congruent vertical angles, so yay. All right, now I can move on and solve for y. All right, so if I'm solving for y, you have two options now. You can recognize that these are vertical angles, right? The angles that contain the y's. So I could totally set y plus 75 equals to 3y plus 5, and I can solve that equation. I'm going to go ahead and do that really quick. So 2y equals 70, so y is 35. Now, that's not the only way I could have solved for y, of course, right? Because I could use, instead of the vertical angles, I can use the fact that I have linear pairs, right? And if the 3x plus 7 is 70 degrees, then I know already that that angle of y plus 75 has to be 110 degrees because he's the supplement. And so I can just set the equation y plus 75 equals 110, subtract 75 away, and what do you know? I get y equals 35. Okay, so you have there's different variations of relationships that you can find in your pictures. I'm going to erase that since I just talked about it. All right, so you don't have to use the vertical angles if you don't want to. I am going to check my work though, right? Obviously that does give me 110, and if I plug 3 times 35, that's 105 plus another 5. What do you know? 110. So my picture totally works. All of my vertical angles are congruent. All of my linear pairs are supplementary. So it looks fantastic. Okay. All right, let's go try this one really quick. Now this one we run into a slight problem. We can't solve this one exactly like we did the last one because if I try to use the vertical angles, one's in x terms and one's in y terms, and I don't want to deal with that. So I'm going to hunt for another relationship, right? So it looks like if I only want to work with x's, I can look at these two. Okay, I don't know why that just made a trapezoid. Okay, we'll just not even do that. Okay, so I'm just going to do this. So if we notice that that is a linear pair, therefore they're supplementary. Therefore, the 6x angle must add to the 15x plus 75 degree angle, and they have to equal 180. So that's where I'm going to want to start on this problem, right? I want to find that linear. Here, I'm going to write it like this. Right, I have a linear pair, and that's the first clue I want to be finding. So I know they have to add up to 180. So that's going to give me 21x equals 105, so x equals 5. And you know me, before I move on, I need to actually check that work. Plus, we're going to be using these numbers to solve for y. So if your x is wrong, then your y is automatically going to be incorrect. So you totally want to check those answers. So that's going to give me a 30-degree angle here, and then 75 plus 75, what do you know? 150 degrees, right? So they are definitely supplementary, and my answer is x equals 5. But I still have to go solve for y, but again, you have options, right? So to me, the quickest way would be to use your vertical angles now, right? Because I know this angle and this angle have to be congruent because they're vertical angles. So I know the 3y has to equal the 150, right? Vertical, let me write that over here, vertical angles theorem, right, is what's allowing me to set that equation up. Well, how simple, just dividing by 3 and you get 50, voila, right? Or if you wanted to, you could use the linear pair here, right? Because we already know the 6x is 30, so we could use 30 plus 3y equals 180 and use the linear pairs relationship. And you can see when you solve that, you're automatically going to get right back to that 3y equals 150, so y equals 50. So no matter what relationship you prove, right, we're still going to get that y equals 50. All right, the last thing I want to talk about is more of these story problems, very similar to the one that was up here at the very top of the page. The ones on our notes are quite simple, but they're not going to stay this simple, okay? So sometimes you can draw a picture and it's nice and easy like the one we just did. I'm going to go ahead and do that for this one really fast because it's really easy to draw a picture for. The measure of one angle is 38 less than its complement. Okay, well I can draw a picture of that because all you mentioned was two angles that are complements. That's an easy picture. All right, so here's my picture of complements. One angle is 38 less than the other. Okay, well one of them clearly has to be x and the other one is 38 degrees smaller. So x minus 38, right? 38 less than its complement. And then once I have my diagram, I'm set, right? I can add them together and set them equal to 90 degrees since they're complementary angles, right? And so we're gonna get 2x equals 128, so x equals 64. Right, and so then I know that one of my angles is 64 degrees. The other angle is 38 less, which would give me 26. And before I box it up, I just want to make a double take and make sure those add up to 90, and they do. They are definitely complements of one another. Okay. The problem is not all questions are going to be easy like this one, because what if I, for example, what if I gave you, what if I told you half the complement of an angle is 5 less than twice its supplement? Do you see how I mentioned complement and supplement of an angle in the same sentence there? I'm not going to be able to draw that diagram. I'm not going to be able to draw an angle who is both supplementary to something and complementary to something else. It's going to be awful. So if you happen to run into a sentence that is complex like that, you're not going to want to draw a picture, and sometimes you can't. So just translating it as a verbal sentence into an algebra equation is going to be the way to go. And I almost prefer to do it this way all the time anyway. So I call this the write it as you read it. You did this a lot in Algebra 1, right? Translating verbal sentences like a number is 6 less than twice another number kind of thing. All right, so write it as you read it. The first thing that you always want to find is the word is. All right? Is in math translates into equals, right? That is my equal sign. Right? Like 2 plus 3 is 5, right? So everywhere you see the word is, that is my equal sign, which means everything on the left, right, translates and is on the left side of my equal sign, and all the other verbiage is going to go on the right. So I'm basically just going to write it as I read it. Okay, so here we go. The measure of what angle? Well, I don't know the measure of the angle. That's my unknown. So x is 38 less than something. Okay, so that means my minus 38 actually goes on the end. And it's 38 less than what? Its complement. Well, let's think about this. How do I find a measure's complement, right? The only way, if I told you that an angle was 50 degrees, what would its complement be? 40. And how did you get that? Well, I took 90 and I subtracted the angle from it, and that told me its complement. So anytime you see the phrase its complement in a verbal statement, you're going to replace it with 90 minus x because that is how you calculate an angle's complement. And voila, now we have our equation. An angle is 38 less than its complement. I just wrote it as I read it, and then I can solve it really quick. I don't really need the parentheses here, but I always like to put them in just in case. So I'm going to add the x, right? And then I'm going to subtract, so I'm going to get, what, 52? Right, and then I'm going to divide, and I'm going to get 26. Oh, what do you notice? 26 degrees is one of my angles, which is exactly what I got, but I got that the second time around over there, which of course means my other angle is 64 degrees. So my little yellow box down here is just a little reminder. Whenever you're translating a verbal statement, anytime you see its complement or an angle's complement or something like that, you're going to be replacing it with the phrase 90 minus x, because that's how you find its complement. And anytime you see its supplement or an angle's supplement, you are going to, of course, replace that with 180 minus x, because that is how you do that calculation. Okay? All right, that finishes actually Unit 1 with our angles. And let me know if you have any questions on the homework.